In this video, we'll cover how to find the inverse of a logarithm. Okay, so just to kind of show you the general case, remember that y is equal to log base b of x. This x may or may not be in parentheses. It just depends on the problem. As I've shown you in the past, to find the inverse of any function, you first go ahead and switch your x and your y. So I'm going to rewrite this with that step. X equals to log base b of y. Okay, and then what we're trying to do is we're trying to isolate the y. So we're going to solve for y. We're going to go ahead and do that by rewriting this. So this right here, we're going to rewrite it using inverses. So I would start with my base, come around and around. And we learned this in class. Okay, so when I do that, this will be b, which is my base, to the power of x is equal to y. And this operation pretty much gets rid of that logarithm right there. Okay, so as you can see right here, the y is already by itself. We're just going to rename it. That way we don't have the same name. So it would be y inverse. Remember, negative, that little -1 means the inverse. The inverse of y is equal to b to the power of x. And that's it. That's our general logarithmic function, the inverse of that. Okay? We'll talk about the graphs in a different video. Let's go ahead and do a more complicated problem. Not so much, just a little bit more by applying some numbers. So let's say we have, so this is example 2. Let's say we have y equals log with a base of 3 of x plus 2. Okay. As I mentioned in the previous example, we're first going to switch our x and y. So x is equal to log base 3 of y plus 2. Okay. And at this point, we want to try to solve for our y. So I'm going to try to get y by itself. Since I don't have anything over here or in the front of this or below this, I can go ahead and start rewriting right away. Okay, so I'm going to find my base. So again, here's my base. And I'm going to do my little trick here, go around and around, and rewrite this entire equation right here. So I'm going to have 3 to the power of x is equal to everything inside the parentheses. So y plus 2. Now, as you can see, we're almost done, but we still have that 2, so we do need to move it. So let's go ahead and do that. I'm going to subtract 2 from both sides. And that's going to leave me with all of this. Now, please keep in mind, you're not going to actually do 3 minus 2. 3 is already compromised with that little power up here, 3 to the x. So we're going to write it out like so. 3 to the power of x space minus 2 is equal to y. And we're kind of done here. We just want to get that y rewritten with a different name. So we're going to call it again y inverse. So y to the power of -1, which means the inverse of y, is equal to 3 to the power of x minus 2. One way to kind of check these to make sure you're doing the right thing is to look at the original function. So this was our original right here, up here, and compare it to our answer, the inverse. So if you notice, the 3 is still a base, but now it's a bigger 3. Think of it that way, small 3, big 3, opposites. Our 2, which used to be on the inside of the parentheses, is now on the outside, and instead of being positive 2, it's -2. So everything is the opposite, which is the definition of inverse in layman's terms. Okay, so let's go ahead and do another one. We're going to do a few examples. So this is example 3. And let's go ahead and do one a little bit different. So y equals log base 5 of x, and then -8 on the side. So just like before, we're going to go ahead and switch x and y first. So x equals log base 5 of y minus 8. And we're going to try to get the y by itself. Okay. In this one, we do have minus 8 over here. That's not part of the logarithm. So we cannot rewrite this until we only have log with, some stuff inside the parentheses. If we have extra things like this 8 or something in front of it, we need to get rid of it first. So we're going to go ahead and do that. We're going to go ahead and move that 8 by adding 8 to both sides. And that gets rid of the 8 over here. And it leaves us with x plus 8, this right here, is equal to log base 5 of y. Okay. Now, if you notice, there's nothing on the right side or the left side, so we can go ahead and rewrite now. So let's go ahead and do that. Start with our base, so 5 to the power of all this is equal to y. So let's see what that looks like. 5 to the power of x plus 8. Now be careful here because some people get confused. Even though it's two terms, all of this is still going to be in the power. Okay. So 5 to this is equal to whatever's in the parentheses, which is just y. And guess what? We're done because the y is now by itself. So let's just rewrite it in terms of an inverse. So the inverse of y is equal to 5 to the power of x plus 8. And again, if we want to check, notice that our 8, which used to be negative, is now positive. It used to be on the outside of the parentheses, and now it's part of the exponent. So think of the exponent and the parentheses as like the equivalent. So it's now inside, which would be the top part right here. Okay. Some of you might pick up some of the shortcuts to this, and that's fine too, but I'll let you figure that out on your own. Next example. So we're on example 4, I believe. And this will be the last one. We have y equals log base 10 of x plus 7 minus 6. So I'm doing a combination problem now that has the same properties of the last two examples, but put together. Okay, so let's go ahead and do the first step. The first step is to switch x and y. So x equals log base 10 of y plus 7, and then minus 6 on the side. As noted previously, we have an extra term out here, so we're going to get rid of it by adding 6 to both sides. And that gets rid of it for us. So we're left with x plus 6 is equal to log base 10 of y plus 7. Okay. Now that we have the logarithm by itself, in other words, there's nothing in front, nothing behind it or below, we're going to go ahead and rewrite this. So we're going to start with our base, which is 10. So 10 to the power of all that is equal to all of this. 10 to the power of x plus 6, that's a 6 right there, is equal to y plus 7. Okay, we're almost done, but if you notice, we do have a 7 over here by the y, so we're going to go ahead and move that now by doing minus 7 to both sides. And that effectively gets rid of this over here. So over here, we're left with 10 to the power of x plus 6 minus 7 is equal to y. And again, we can't actually do 10 minus 7 equals 3 because 10 is compromised right here with this x plus 6 right here. Okay, so we have to leave it alone. And we're kind of done. We just need to rewrite it with a different name because we can't have y equals two different things. So let's go ahead and do that. We're going to have the inverse of y, which is denoted by that little -1, is equal to all of this, 10 to the power of x plus 6 space minus 7. And again, comparing to the original problem, our 6 used to be negative. Up here, our 7 used to be positive. 7 is now on the outside, it used to be on the inside. And the 6 used to be on the outside, now it's on the inside. So everything is opposite. And that's it. That is how you do the inverse of a log.